Avogadro's law states that the volume of a gas is directly proportional to the number of moles of gas when the temperature and pressure are held constant. The mathematical expression of Avogadro's law is V is equal to K multiplied to N, or V sub 1 over N sub 1 is equal to V sub 2 over N sub 2, where N is the number of moles of gas and K is a constant.
For the first problem, we have a 6-liter sample at 25 degrees Celsius and 2 atmospheric pressure that contains 0.5 mole of a gas. If an additional 0.25 mole of a gas at the same pressure and temperature are added, what is the final total volume of the gas? For the given, we have 6 liters for the initial volume and 0.5 moles for the initial amount of matter. The final volume of the substance is unknown, while the final amount of matter is 0.75 moles. The formula for the Avogadro's law is initial amount of volume over initial amount of matter equals to final amount of volume over final amount of matter. Substituting the given to the formula and simplifying, we have the final volume as 9 liters. For our second problem, we have 11.2 liters sample of a gas is determined to contain 0.5 moles of nitrogen. At the same temperature and pressure, how many moles of gas there be in a 20-liter sample? For the given, we have 11.2 liters initial volume, 0.5 moles for the initial amount of matter, 20 liters for the final volume, and an unknown for the initial amount of matter. The formula for the Avogadro's law is initial amount of volume over initial amount of matter equals to final amount of volume over final amount of matter. Substituting the given to our formula and simplifying, we have the initial amount of matter as 0.89 moles.
If 11.2 liter sample of gas is determined to contain 0.5 moles of nitrogen, at same temperature and pressure, how many moles of nitrogen would be there in a 20-liter sample? Using the formula for Avogadro's law, the initial volume times the final number of moles is equal to final volume times the initial number of moles. We can find the unknown, which is the number of moles of nitrogen in a 20-liter sample. The initial volume given is 11.2 liters, and the final volume, which is 20 liters, and the initial number of moles, which is 0.5 moles of nitrogen, and the unknown, which is N2. Substituting the values, 11.2 liters times the unknown, which is N2, is equal to 20 liters times 0.5 moles of nitrogen. Multiplying this, we can find the answer is 10 moles of nitrogen is equal to 11.2 liters of the 11.2 liters times the unknown. Then we need to isolate the unknown, which is N2. So dividing both sides by 11.2 liters, canceling the unit, which is liters, we can find the answer, which is 0.89 moles of nitrogen in a 20-liter sample.